All right, this is part two of the square root and cube root graphs. So this is going to be a practice grade here. So in order to keep all the classes together, we're going to do this second part here, and then the other lesson this week is going to be on finding the average rated change on Desmos also. So we've been doing a lot of Desmos lately, but we'll do some other activities. But this week we're going to do two more Desmos activities. So this first slide is just how you're feeling today, and it's a slider. So if you want to say more, then you can. Let me get on the student preview here. So I'm gonna slide this along here. So however you're feeling, and if you want to add something to that. All right, so one at a time, move the sliders H and K. What happens to the graph as you change A? If A is negative, what happens when you change H? What about K? So we covered this last week, just a review here. So A, if I make A larger, it dilates the graph with respect to X. If I make it negative, it reflects over the X-axis. And then H moves the graph left and right. So if H is positive, so you have X minus a positive number under the radical moves right. And then X minus a negative number would put X plus some value under the radical. And that moves to the left. And then K moves the graph up and down. Let's make this a 1 here. Okay, moves the graph up and down. Let's make this a 0. So I make H at 0 and then just move K here. So I slide a K. Having trouble with my mouse here. So sliding K. Positive up, negative down. All right. What transformations are happening to create the new red graph? How did it change compared to the parent function, which is the cube root of X? So here's the original, and here is the transformed graph right here. So in this case, A equal 2. So dilation by a factor of 2. With respect to the x-axis. And then K. Oh, H. Let's go to H first. H is negative 1. It translates 1 unit to the left. So if I have a plus under the radical there, plus 1, that means that H must be negative 1. And then K, I just picked the value off for K. It's negative 5 there. So translates down 5 units. All right, and then number 4, the domain. Let's see if I can just type negative infinity in here. Negative infinity. infinity. So if I do type the word infinity there, it just changes to the symbol. Range is negative infinity to infinity. Point of symmetry is right here. And if I look under the radical, it would be -1, -5 would be the point of symmetry. Find by h and k value there to find the point of symmetry. The decreasing interval, this is NA. Now, if I try to do slash, it's gonna, I'm just gonna say never decreasing. And the increasing interval is the same as the domain, negative infinity to positive infinity. All right, so what transformations happening to create the new orange graph? How did it change compared to the parent graph? The square root of x. So once again, you want to find a is -1. So reflected over the x-axis. And then h equal 4. So it translates right 4 units. And k is -1. So what's the domain of the graph? So the first x value I see going from left to right is a 4. It includes 4, so I'm going to do the square bracket 4, comma, infinity. Close the parentheses there. Oops. I want to bracket around the 4. It includes 4. And then for the range starting at the bottom is negative infinity. And it goes to -1 in square bracket. Includes -1. The endpoint, I look right here, for -1. I can see my x value and my y value in the domain and range there for the endpoint. So 4, comma, -1. And then this should say endpoint. The point of symmetry is none here because it's square root. Endpoint is 0, 0. I'll sketch the graph on the grid here. So it's going to be difficult using my mouse here. So you're going to flip this or reflect it over the x-axis. And then I'm going to go 5 to the left there. So this point right here. And then if I plug a -1 in there, I get a -2. And let's see what else I can plug in there. A -9. I mean, the next number, if I plug in a 4, I get square root of 9. So 4, -3 right here. All right, and then I'm going to try to draw a graph through there. Carefully drawing that graph. Oh. I'm dragging my mouse here and it's not. There we go. All right, let's connect this together a little better. All right, it's not the best graph, but some of you will be able to draw that a little bit better. So endpoint, there is negative 5, 0. The domain begins at negative 5. So square bracket to infinity. Parentheses range, starting at the bottom, negative infinity, and then it goes to 0 in the square bracket. Increasing, never, decreasing from negative 5, comma infinity, like the domain there. All right. Next, this does have no endpoint. It has a point of symmetry. So we want to sketch this again. Let me see if I can plug in my slate here and get it to work, because that would be much better than me trying to draw with a mouse there. So let's see. Oh, let's see if I can get this slate going here. So if there's a minus 5 under here, that means I'm on 5 to the right. So 5 and then up 1. So that's my new endpoint. If I plug in a 6 there, I get 6, 2. If I plug in a 4, I get 0. And let me see, what else can I plug in there to get a nice integer value? So the cube root of 8 is 2. So how can I get 8? I have to put a 13. That's off the grid space. And if I want a negative 8 under, then I put a negative 3. So negative 3 here. 1, 2, 3. If I plug in a negative 3, I get a negative 1. So that's that point there. And then, like I said, 13, 4 would be a point, or 13, 3. So 10, 11, 12, 13, 3 up here somewhere. So let's see if I can sketch this now. I think it's a little bit better with the slate here. There we go. A little bit better than doing it with a mouse. Okay, so now my point of symmetry is 5, 1. And there's not an endpoint. The endpoint is for the square root. The domain is negative infinity to positive infinity. And the range, same. Increasing from negative infinity to positive infinity. is never decreasing. All right. Well, this is a lot of graphs and equations to match up. So I think I might start with the ones, the square root ones here. Oh, trying to drag that, it's not dragging. So let me see here. This has an endpoint at -1, 3, so these two match up. Let's see if I can move that. No, I can move it. All right, this one is reflection, where the endpoint is 3, 1. So it goes here. I got to get this so I can drag it. There we go. All right. Some things are in the way here. This would be -1, +3. -1, +3. Let's move these out of the way here. See if I can move them. Oh. Let's see, this one is a cube root. 3, 1. That's this one. See if I can drag it over there, on there. There we go. It's a little bit cluttered here. All right, here's a square root where it's -3, 1 is the endpoint, and then the opposite. So -3, 1. And the reflection is this one. If I had better mouse skills, I might be done with this already. There we go. This is messy. Why did this come apart? There we go. Hey, that didn't. What just happened there? I switched these around and I don't want to. Oh my goodness, this is annoying. Why did those join together? They're not right. Can't get this on here. There we go. All right. One. This should be -1, -3. And this one is 3, 1. There's that one. Maybe if I do it this way. Alright, so I digged at the characteristics here. Something wrong here. It's not right. That's this one. Get that off of there. No, it's right. I don't know what's going on here. Here I want the square root graph that's 3, 1. And going up. It's this one. What is that? How did I get that one on there? Oh my goodness, when I get near something, then it just attaches. I thought it wasn't supposed to attach unless it was correct. So this one goes here. 3, 1, 3 to infinity. Oh, that was one. That's one is going down. It's over here. And this is going from negative infinity to positive infinity, negative infinity to positive infinity, increasing. Why is these two joined together here? This goes here. Endpoint -3, 1. Let's see that one. This goes here. 0 symmetry 3, 1. Let's get this off of here. I thought I had this in the right place. I did. You need to drag this over here. All right. I think I have everything matched up now. Let's make sure that's right. So this is endpoint -3, 1, or -1, 3. Domain -1 to infinity, range 3 to infinity, increasing -1 to infinity. That looks right. The cube root of x -1 plus 3. So this point of symmetry is 1, 3. This is endpoint -1, -3. Here are the endpoints 3, 1, domain 3 to infinity, range 1 to infinity, and increasing 3 to infinity. This one's a cube root. The point of symmetry 3, 1, domain -infinity, positive infinity, range same, increasing, same. It's always increasing. And then let's see this one. 1, 3. This goes here. And point of symmetry 1, 3. That goes over here. Now everything is finally right, I think. Oh, he's over here. It definitely took a while with my mouse skills and things were connecting together that I thought on this activity it'll only connect together if it's correct, but maybe I'm wrong about that. So this looks right. This first card on the left. This one looks right now. This one looks right. And this one looks right. This one, point symmetry 3-1, domain and range increasing, that looks right. Here, 3-1, and then the reflection, that's right. And then this one, process of elimination should be right. So move it up here for a second. So reflected, -1, -3-1, domain is right, range is right, decreasing is right. So everything is correct. All right, sketch the inverse below. So what you do is, this point is to 1. So I want to go to 1, 2. And then 3, 2 becomes 2, 3. And then 1, 2 becomes 2, 1. 4, 5 becomes 5, 4. 0, 5 becomes 5, 0. Let's see if I can draw a graph in there. Oh, here we go. So we got a parabola on its side here. Let's undo that. All right. How can we restrict the domain of the original function, the red graph, so its inverse will be a function? So if I say x is greater than or equal to 0, or 2, I mean. So this vertex is at 2, 1. So if I just graph the inverse of this branch, it would be this top one. Or I could say x is less than or equal to 2. And I would just get the original, I'd just get the right of the left branch. And then the inverse of the left branch would be the bottom one. All right, so in order to get the inverse to be a function, then I have to either have just the right side of the graph or the left side. And I would start at this vertex here. So x greater than or equal to 2 would be the right side, less than or equal to 2 would be the left side. And then the inverse would also be a function. All right, that's it.